In this question, we're asked to show that the limit of x approaches 2 of x over x minus 2 does not exist. So let's jump over to GeoGebra, see what this function is actually looking like and behaving, and we can see from the points that this thing's going to go off to infinity. So here's the function. Clearly at x equals 2, the function's starting to shoot up. Let's just type in 1, 2, and 3, and we'll go equals f of a1. So f of 1 is negative 1, which you can see right there. Plug in 1, you get negative 1. Drop it down. We have infinity for 2, so f of 2 doesn't exist, and f of 3 is 3. So similar to last time, let's start narrowing in here. Let's go 1.5, 2.5, okay, negative 3 and 5, 1.9, 1.9 is negative 19. So these numbers, 2.1, are actually getting further and further apart. 1.99, almost 200, and 2.01, 200 as well. So these are not approaching a number. In fact, as I get closer and closer and closer, in fact, if I just type, I won't even do it, but if I type in a bunch of these 9s, it'll end up saying infinity as well, just because of the rounding. But we can actually go and see what happened. So we can see that happening with the graph and the table. But mathematically speaking, if we just type in, let's say 2.1, so the limit of x approaches 2 of 2.1 over 2.1 minus 2, well, that's going to be 2.1 over 2.1 minus 2 is 0.1, which is the same thing as 1/10. Okay, and then we can do this little reciprocal, 10 over 1, 10 over 1. Those will cancel, and I'll be left with 2.1 times 10 over 1, which I don't need to write. That's 210. Now, if this was 1 over 100, add another 0 here. 1 over 1,000, add another 0. 1 over 10,000, add another 0, which means this number, as it gets closer and closer to 2, this number here, this number will get bigger, which means it does not exist.